Welcome to the topic of integration. Today, we will explore the method of substitution using an important integral that involves the function of 2 times x times the cosine of x squared. This will help us understand a key technique used frequently in calculus. First, we identify the integral we are working on. This is a crucial step as it sets the foundation for our next actions. We have an integral that combines multiplication by the variable and a cosine function, making it a prime candidate for substitution. Next, we will choose a substitution to simplify our work. We will set u to equal x squared. This substitution is advantageous because it helps simplify the expression involving the cosine term significantly, guiding us toward a more manageable integral. Now that we have our substitution, we need to differentiate it. By differentiating u, we uncover a key relationship. The differential du equals 2 times x times dx. This relationship is not trivial. It underscores how we can express dx in terms of du and x, which is a vital step in rewriting our integral effectively. With the derivative clear, we can proceed to rewrite our integral in terms of our new variable, u. Recognizing that we've defined u as x squared allows us to replace the expression 2 times x times dx with just du. This clever transformation makes our original integral much simpler, aligning perfectly with our substitution strategy. Now it's time to integrate. The integral of cosine of u is a foundational result in calculus. It equals sine of u plus a constant of integration. This isn't just a rote fact. It represents a shift from the process of integration to actually applying what we know.